Hi everybody, I'm Mr. Polly, and welcome to Podcast 10.1, where we're going to talk about properties of acids and bases. No trouble. We're going to list common products that are acids and bases, including vinegar is acetic acid, and ammonia is NH3, and this is a base. Explain acids are proton donors and bases are proton acceptors. Explain the definition of acids and bases, and use them to identify substances as acids or bases. Define a neutralization reaction. Difference between strong and weak acids. Identify strong and weak acids and bases. So let's roll. That's what Mama told me. Worry about your acids and bases. Taste. So I'm going to run right through this. They taste sour for an acid, and a base is bitter. Sour is like lemons and stuff, and bitter. Olives is, and there's bitter chocolate, but that's kind of tough to do. An acid, oh, don't do this to me, is sticky. And a base is slippery. Litmus. This is an easy one to remember. If it is red, it is an acid. If it is red, acid. And if it's base, it's blue. Red, acid. Phenolphthalein is colorless. And these are the indicators that are most often used in lab. And base is pink. Conductivity, they're both yes. It's either strong or weak, but they will conduct electricity. So light up a light bulb, for example. pH, an acid's pH is less than 7. A base's pH is more than 7. And we talked about that in class a little bit. If you add a metal, it bubbles. Get back here. It bubbles, which would mean it reacts. And this one would be no reaction. This one bubbles. This would be no reaction. By the way, this is a joke. It doesn't feel guilty. It doesn't really, it's not sticky or slippery. Oh, that was the trick. This computer got me. Can I write? Oh, it won't let me write. Okay. Little ghost, can I write slippery? Gotcha. Litmus won't change if it's neutral. Phenolphthalein will stay clear. Conductivity is mostly low or none. And that's important to add. pH is 7. And if you add a metal, no reaction. It's weird how this is coming and going. So what is vinegar? We talked about how vinegar is an acid. And something that helps is food is typically an acid. If you have to try and identify it. And cleaners are often bases. And that's because cleaning things dissolve organic, and organic is like living things, which cause most of the funky, disgusting things in the world. Ammonia is a base, and ammonia is like Windex. Cleaning supplies, hey, I think I just said that's a base. OJ is orange juice, not the guy who may or may not have killed his family. And orange juice is a food, and it's an acid. Gastric juices are often called stomach acid. And this one is tricky. I said most foods are typically acids, but a banana peel is slippery. Let's see if my computer let me write the Y. It did. Woohoo! So it's slippery, so it's a base. Ding, 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 ding. Ah! Indicators tell you the pH. Now, on this, you can do this with labeling it. You don't have to color it with crazy colored pencils or anything. And I actually have extra ones in here. But you're going to have to be able to do interpretations like this. Find the pH of phenol red is yellow. Here's phenol red. And bromethymol blue is yellow. Bromethymol blue. And chlorophenol red is red. So what happens is I have a sample, and I drop it in these things, and I look at the color. So if phenol red is yellow, that means, go to the right one. Phenol red is yellow, that means it's less than 7. If bromethymol blue is yellow, that means it's less than 6.5. So a little bit better. And if chlorophenol red is red, this is about the splitting point, that means it's more than 6. So what's the pH of it? I just misspelled between 6 and 6.5. 6.0, I suppose, and 6.5. Chemistry of acids and bases. So acids and bases for us right now. Acids. So if you can throw it on your face, my face is melting. is for chemists is an H is an acid is an H giver. A base is an H taker. Now, what acid should be for us, having taken chemistry so far, is, hello, I'm an acid. Acids start with H. And this is true about 95% of the time. We're profiling acids. Most acids start with H, that's true. This is an acid. This is an acid. It's going to give its H to water. Oh, look. Oh, how sweet. And it's going to be Cl negative. Okay? So it's an acid starts with an H. Now, we know water isn't really an acid, and it won't be for us very much. Here, I have NaOH. It doesn't start with an H. It does start with an H. It's going to give its H. Oh, and it gives it to the OH and splits it. So I get water. And then I get NaCl. Okay? And we'll talk about that a little bit more. First of all, when we get H positive and H3O positive, it's the same thing. Remember, H positive is a bunch of emptiness. Hydrogen has just one electron. Hello. Hydrogen has just one electron. And H positive is just H that's empty. But it has a positive charge. Water, if you recall, looks like this, and it has these big, attractive electrons right here. And H positive loves these negative electrons. Oh, I'm going to go over here, and we're going to form a bond, and we're going to be happily married forevermore. And that's what happens. It turns into H3O positive. And that happens pretty much 100% of the time. So it's the same thing. So H positive loves negative electrons around water and bonds, like the annoying couple in the hallway. How can they always be together? There's like the stairway that's Makeout Central in high school, and I swear that's where the security guards should be, but I think they just don't want to see it either. Neutralization. The word neuter means to take away your identity. So, if an acid is neutralized, it is no longer an acid. If a base is neutralized, it no longer is a base, and it doesn't have those properties anymore either. If a puppy is neutralized, oh, I guess it's still a puppy. Or neutral. It's still a puppy. Come on, pen. You can write for me. There we go. So HF plus NaOH, what I get, my H, remember H's and OH's love each other like the people in the stairway, and they get H2O. You can also write it HOH if it makes you happier, plus NaF. Now remember, our water is not an acid or a base for us, and this isn't an acid or a base. So what happens is I started with an acid and a base, and I ended with water, and then this is an ionic compound, which is really called salt. So I get water and a salt. Examples. Hello, I'm an acid. Hi, I'm a hydroxide. So I get H2O, and then I get the leftovers, KNO3. Here I have an H and an OH. That'll give me water, and that'll give me FeNO2 taken twice. Where did that come from? Oh, looky, looky, looky. Iron here is +2. And nitrite, pardon me, is -1, and I need to balance those charges. Hey, I remember that. So this is water. And this is an ionic compound. Oh, look here, this is a K positive and an NO3 negative. So that's an ionic compound we'll call a salt. Hey, look, water, salt. Acid plus base makes salt and water. Strong acids and strong bases. Strong acid and bases ionize 100%. Strong acids are these three. Strong bases are group 1 and 2 hydroxides. What does that mean? This is group 1. This is group 2. Okay? So remember, acids start with an H. Hello, I'm an acid. And strong bases are group 1 and 2 hydroxides. So HNO2, this is an acid, and it is weak. Why? Because it's not one of those. This is a base, and it is strong. It's a base because it's a hydroxide, because calcium is in group 2. Get back here. This is a strong acid, starts with an H, and this one, remember I said we had to memorize it? It is a weak base. Concentration does not equal strength. Strength is how much you separate. Concentration is how packed in you are. So concentration, if it is 1.0 molar or more, you are concentrated. If you are less than 1, you are dilute. Remember, to be strong, you have to be one of those magical ones. This is one of the magical ones listed as strong. Strong, weak acid. And it's weak because it's less than 1. This acid is on our list. It is a strong, look, it's more than 1, concentrated acid. HNO2 is not HNO3, so it is a weak, dilute acid. Not on our list, but still an acid. Hello, I'm an acid. Hello, I'm an acid. Weak. Whoops. Weak, concentrated acid. Here's a base. Hey! And it's going to be concentrated. And it is a strong base because Na is in group 1. That is it. I got to run, so enjoy our review. Toodly oodlies.